Well, good morning, good afternoon, or good evening, everybody, depending on where you're joining us from. I want to welcome everyone once again to another community conversation hosted by the Autodesk community. My name is Chris, and I will be your community host today. It's my pleasure today to welcome Kieran and George, who will be talking about machine simulation with Fusion 360 manufacturing. So just a bit about our series here for those of you who are joining us for the first time. Community Conversations are virtual meetups featuring expert speakers from across the Autodesk community. Sessions range from deep dives, tips and tricks, live demonstrations, and so much more. All experience levels from beginner to expert are welcome to attend these. We always share with you our safe harbor statement at the beginning of these, just in case if any forward-looking statements are made during these sessions. We want you to please do not make any purchasing decisions based on anything that is forward-looking. If you're making purchasing decisions about software, look at the state that it is in today and that alone. Okay, get that out of the way. So we do have everybody's lines muted to reduce background noise, but we want this to be a conversation. So you're invited, if you feel comfortable to do so, to turn your camera on. And if you have a question or a comment at any point during the session, feel free to throw it into the chat or use the raise hand feature on your Zoom menu, and we will jump right in and grab that question from you. The session is being recorded and will be posted to the community conversation site for this session after the session is completed, and will be emailed to all attendees. So I'm going to put in the chat right now a link to today's session, so you can go ahead and bookmark it if you want to, and that way you can get back to it easily to get the recording and to continue the conversation when everything is done. All right. So with all of that out of the way, you didn't come to see me, you came to see Kieran. So I'm just want to quickly introduce myself because I'll be here in the background handling questions and letting people into the room when they join. My name is Chris. I'm the community manager for product design and manufacturing. I am not a Fusion 360 user yet, although I am learning. So please don't hold against me the fact that I am an inventor user. That's where my background is. And former expert elite, former Autodesk University speaker who joined the community team just about 2 years ago so that I could be here to help you guys. And with that, I'm going to stop sharing my screen now and hand it over to Kieran. And Kieran, it is your ball game from here.
Thank you very much. Right, let me give that a share. Right, just a quick check. Can everyone see my screen? Hear me okay? Brilliant. Okay, so welcome everybody. Super excited to have you all here. So my name is Kieran Gill. I am one of the customer advocacy managers here at Autodesk as part of the customer engagement organization. And my real responsibility is to help customers kind of achieve their manufacturing goals by 3 different metrics. One, how we validate things helps them, how we demonstrate the technology to them empowers them, and how we educate them helps them achieve their manufacturing goals. So that's part of my responsibility. I got my bachelor's degree in mechanical engineering here in the UK from Oxbrookes University. And I've been working for Autodesk for approximately 10 years in different areas. Started off in the dental industry, manufacturing miniature dental implants on various different machines. And then kind of moved into the industrial CAD/CAM side, and now work in the Fusion organization. And I'm now in my 10th year at Autodesk, so very, very exciting. Okay, so straight on to today's topic is we're going to be having a look at the basics and how you go about getting started with machine simulation and machine builder. Once we've actually, and part of that process is we'll actually dive into the product, we'll have a look at it, we'll touch on various topics, we'll briefly touch on things like the post-processor as well, and then we'll touch on what's coming next for machine simulation and machine builder, and broadly simulation in general. And then we'll kind of open it up to Q&A at the end. But again, like Chris said, if there are any questions, please post them in the chat, and I'll hopefully stop and answer them as we go. Okay, so that wasn't the right one. We actually want to go straight into the demonstration. So let's go into Fusion. Now, first off, from the bat, I'm just going to close off my data panel just to kind of increase the real estate. So first things on the screen that you can see is a mold for a headlight. And there's a couple of toolpaths on here. There's a flat machining strategy. There's to machine, obviously, the flat areas. There's a steep and shallow strategy to machine the doubly curved surfaces, the fillets, and so on. And then lastly, there's a rest finishing strategy to pick up all of the material that was left over from the toolpaths that came before it. So generally, to simulate, we right-click on the setup itself, and we can simply hit the play button and Fusion starts simulating that. And I've specifically turned off the links and leads and cutting moves just so you can see the tool a little bit clearer. We can then navigate down to the steep and shallow strategy, and you can kind of see, as I kind of speed it up, you should start to see the tool path, or actually the tool tilting. And then you can see this is a multi-axis strategy. And hopefully this will translate into machine sim, where we'll actually see some of the table moving as we kind of get into these multi-axis movements. Okay, so that's just a really quick intro into how you access simulation without invoking the machine. But how do we go about invoking that machine? So we can right click on our setup, we can edit the setup, and from the machine tab, we can go ahead and think about selecting a machine. So the machine library dialog will immediately pop up, and there's a number of things to bear in mind. Now I'm just going to expand this window to just get a better view of the dialog. Now, typically, the recent folder will have all of the machines that you've used in previous documents so that they can be reused for a particular document that you have open. Within the document, you'll see the specific machines that have been used for a particular document. So you may use a HAS machine for setup 1. You may then move that part or that entire setup or op20 over to a DMG machine. So this allows you to have multiple machines available in the documents. You can select them with real ease. Okay. Again, what we can also do is we can have machines that are in the cloud. Now, I've purposefully left all of my my machines area empty because I want to show you some of this as we go along. So cloud machines allows us to put machines in the cloud, and this will be available across teams. So if I was to use a machine, Jimmy down in the other room who's programming another part could simply pick up that machine and use it as part of a project he's working on as well. Locally simply means I've downloaded a machine to my local folder, and it persists across projects. Linked. So if I right click on that, I can now link a folder on my desktop, for example. Now I may choose to have all of my machines offline or on a folder on the desktop. I can certainly link that folder here, and all of those machines will populate accordingly. But how do we go about getting our first machine? Now, fortunately, Autodesk has provided a really good way of getting your first machine. So you'll see there's a Fusion 360 library over here. As soon as I click on that kind of drop down, you'll see a number of different machines. So let's go and have a look at some of them. So the first thing to bear in mind before we actually start to touch on all of this is just some nuances in how these machines are kind of structured. So by clicking on the first one, for example, we can see the model, the make. We can also see the dimensions of the machine and get a good idea of the kinematics of the machine. One thing to bear in mind is that as soon as I turn off the milling, the filter on the milling side, we can clearly see that the got a valid kinematics file attached to it, but it's also got a valid 3D model attached to it. So the 3D kinematics file that I mentioned first is very important, especially for machine sim, because what we're doing is, as part of posting out toolpaths, we are running the toolpaths through the post processor first, and that post processor is actually calling up the kinematics of this particular machine. And so everything you see in the simulation mode when it's using machine simulation is actually being run through the post first. And the reason we did that was to obviously make it as accurate as possible so that what you see on the screen is what you're likely to get on the machine. Okay, so the next thing I want to do is enable the simulation ready checkbox. And what that simply means is that it's got a simulation ready post processor as well. And we'll touch on why that's important a little bit later. So the first thing I'm going to go and do is, for this particular model, we've actually Hi there. Can everyone hear me? Sorry, I don't know what's happened. Just had a Fusion crash.
You were locking up for a few moments on the Zoom as well.
Perfect. Great.
Your video froze.
Perfect. Am I back? Am I good?
At the moment, I would say yes.
Great. Everyone can see the screen. Super. Great. So we'll just jump straight back in and we'll go and pick that machine again, that UMC 750. So we'll just navigate to find that UMC 750, and there it is, and we'll click select. So it's going to ask us now to download that model. What it's then going to say is, hey, where would you like to go and save that model location? Now, a number of questions that come up is, can you go ahead and save that machine in a different folder so that we can use it for other projects? Can we use it elsewhere? And the answer is simply yes. So currently the location that I have open that I'm using today is this machine simulation webinar, but I'm going to go ahead and paste it into a different folder. So what it's going to do now is it's going to go ahead, download that machine, and you should see in the bottom left-hand corner, you'll see some kind of update as it's uploading it, but it's downloading that full 3D model. And then once it's done that, it then re-uploads that model into our current project. Okay, so we'll just bring back up Fusion. Okay, and when we do that, we can see we get this extra tab, which we didn't have before inside of Fusion. Now, this part positioning tab, when I click it, what it'll do is it'll actually bring in our machine that we've just asked for it to bring in, this UMC 750. So as I rotate this model around, we can now see our part positioned inside of the machine. Now, elegantly, Fusion has gone and grayed out or silhouetted out the machine for us, and we can use the drag handles to move our part around. Now, what we've done is we've taken the bounding box of, we've taken basically the lowest point of the bounding box of everything that was selected in the setup, and we've used that lowest point as the point at which we're going to attach the model set to the machine table. So initially, what we do is whenever we bring in a new model, we always send that model to the machine attach point that was specified when that machine model was created. Now, in this case, it's the center of the table. So if I want this point here in the corner of my model to be the attach point, what it'll do is it'll shift that corner to the center of the table. Okay, so let's move that back. Now, if we want to change the machine attach point, we can simply click on the table attach point, and now you'll see it switches around. The model is actually grayed out, and we can now pick other geometry on the actual table, and you'll see actually that the model shifts over to that position. But I'm quite happy where it is, so I can go ahead and click on OK. Now, the keen-eyed of you out there will have noticed that my toolpath has got a warning on it. Let's go ahead and see what that warning is. Now that we've imported a machine and we've specified that machine as part of our setup, we're getting a little warning that the spindle speed is larger than the supported spindle speed for this machine, i.e. the Haas UMC 750. So very interesting. What we need to do now is we now need to go and change that, because what's happening in the background is Fusion's checking all of our toolpaths against the machine kinematics that's been set up. And in this case, our toolpath spindle speed exceeds that of the spindle speed of the machine. So we'll go and edit that toolpath and simply change our spindle speed to something more appropriate. Click on OK, and it disappears. Okay, so now what we can do is we can go ahead and we can say, right, let's go ahead and simulate this toolpath or this setup. So we'll give that a second to load. We'll wait for the simulation file to load itself up, get all the toolpaths in the cache, and we'll just give that a few seconds to load up. Okay, and in the meantime, I will endeavor to check the chat.
We have a question turn up.
So when I set up my machine XYZ limits, the number gets transposed, and the result I can't, and as a result, I can't set proper limits. So does it error out when you simulate, or what happens? Stuart, if you can give us a little bit more information on that, Stuart, that'd be great. Okay, so I'm just going to go ahead, and in the meantime, I'm going to start playing the simulation. You can actually see the toolpath actually go in. And again, I'm not going to waste too much time. I'm going to head over to this, and I'll tell you what we do. Let's just set the viewpoint to the base machine base, because you can have multiple viewpoints. And there we can actually see some of the multi-axis movements on the machine. Now, some things to bear in mind. Okay, so Stuart said, for an example, when I set X at 420, this ends up in my Z limits in the machine file. So one thing, and this is probably a setup issue that you've got, what you need to bear in mind is whenever you're setting up your machine always needs to be positioned in the home orientation first, as part of a general guide, but also the Z-axis should always be pointing up. Now, it doesn't matter where that Z-axis is. So, for example, your origin could be on the middle of the table, or it could be off in some distance, but the Z-axis must always be pointing upwards. So maybe that's the issue, but Stuart, you and I can connect offline as well to have a look at that as well, if that's an ongoing issue for you. That's definitely something we can connect on afterwards. Okay, so we can definitely see that we've got some machine simulation. Things to bear in mind about what simulation does and doesn't do is that currently we do not show, or we do not account for linking moves between individual toolpaths or different setups. We also do not check collisions on the machine. So we do not check, for example, the tabing rotating past its limit and smashing the head. We don't check that at the moment. We don't check things like go home G53Z zeros. We're not checking that at the moment, but we're also not checking 2D and 3D cutter compensation. So when we get to the roadmap, I'll tell you more about what's in the pipeline, what we're working on at the moment. So you do get an idea when this sort of stuff, what we're working on at the moment. Okay, so now that that's out of the way and we know where we are in terms of what's coming, of what's not supported, let's jump into another way we can get machines into Fusion 360. So I've shown you that we can edit the setup and bring in our machines that way. But another way we can bring them in is going to our machine library, for example, opening that up. And let's say, for example, we wanted to pick one of the Autodesk machines. Again, we can pick milling, pick simulation ready, and navigate down here. And we could see something, for example, let's go ahead and pick this machine. Now, what I could do now is click, hold, and drag the machine into my local area. So again, what it's going to do is it's going to say, hey, where do you want to save it? Again, I want to save it into that location. And we'll just give that another couple of seconds to download. And again, this is as easy as it is to get machines into your setup and being able to use them. Okay, so we'll just give that a couple of seconds to copy and download, and then we'll move on from there. So Chris says, Tom, are you asking regarding the Z-axis orientation on a lathe? Thanks, George. Yeah, so great comment from George. Lathes are definitely not supported at the moment, but it is something we're definitely working on. Okay, so let's close that and open up our data panel. And I want to show you where those two machines are actually living at the moment. So you can kind of see the two machines that I've just downloaded over here, the UMC 750 and the machine that we've just copied over to that file location. So two really cool ways and really easy ways to get machine simulation working. So let's go ahead and post this setup out. So something to be aware of, and this is kind of where you start needing to think about the post processor that you're using. So traditionally, what we've had in the past is we've had a situation where all of the kinematics that people use with their post to determine post limits, get errors, check against the machine kinematics, have all been done inside the post. We've now moved away from that, where we've taken the machine kinematics out of the post and we've put them into what we call machine configurations or machine kinematics, right? So the benefit here is that when we do post out, the post is actually checking against a separate kinematics file and then displaying those results in simulation for us. So in order for a post to be simulation ready, you have to actually remove some of the kinematics and a couple of extra bits of code and put them into the kinematics, and we have to update our post. Okay, so here we've got our post, and we're just going to go ahead and let's go ahead and post this out. Okay, and hopefully we'll get a little dialogue that the code's been posted. Okay, and what we'll do as well is we will just post that again, just turn off the post to Teams. Fortunately, I had that checked. So a beautiful option here as part of the posting process is that you can also post your NC code to Fusion Teams as well. The beauty here is that once I do have posted code, I can go and share this across various teams. Okay, we can also see the file that it's associated with as well. So very, very convenient. Okay, so let's just go ahead and disable post to Fusion Teams, and let's just go ahead and post that out again. Okay, so hopefully we should see coming up on the screen in just a couple of seconds is we should see the NC code flash up on the screen. So there we can see a multi-axis setup, which is posted out using Fusion simulation, machine simulation. Okay, so let's just minimize that for now, and let's go in and let's edit our model. Let's edit our setup, and let's go ahead now and change that for one of the models that we recently downloaded. Let's go ahead and pick one of these models. So the Autodesk generic 5-axis machine. Again, let's just go and check that we've got the positioning right on the machine. I'm quite happy with that. We can click on OK. Okay, now we can go ahead and simulate this, but I'm pretty happy with it. So we're going to go ahead and post this straight out. Now, interestingly, note the post. The post is now changed from a post which is has specific to a post which is what we call the machine simulation post. Now, typically for machines that don't have a post assigned to them, so Autodesk machines are a great example of this. They're not a manufacturer, they're a fictitious bunch of machines like the one we've got on screen. We've included a machine simulation post. So what this will allow us to do is to test that machine simulation works before we actually go and change our own posts, and also implore other third parties to make changes for us to our posts. So again, what we'll do is we'll call this something else, and we'll go ahead and post this out. Now, the bit that I want you to be aware of here is once you've posted out using this machine simulation file, you'll see we actually don't post out any code. And it's specifically for that reason that we don't post out any code. It's just to make sure that we can check and validate what we're seeing on screen. And it's basically to use to test machine simulation. Now, George has created a number of articles, and if you click on that link as part of that output in the NC code, it'll take you to this specific link. So this will explain why we've got the machine simulation post, but also the link and kind of walks you through the process. The video up top was created by me, so it kind of walks you through both aspects. But then the link down here actually talks about how you can go configure your own post by adding bits of code it's a couple of lines of code, really. It's quite a short document, and how you can go and make your post simulation ready. So that's really useful to know. And that link in the output of the NC will actually take you to this. So just something to be mindful of. Now, all of the posts that are available to users. So we'll just go and have a look at some of those simulation ready posts. So if I go and open up the post folder at the moment, and we go to our library and we enable the machine simulation, we can currently see all of the posts which are machine simulation ready or machine simulation capable. So we've got FANUC, we've got Haas, we've got Mazak, Makino, Herco, Siemens, Heidenhain, all of them are in here, and they're all simulation ready and capable. So you only typically will use the Autodesk machine simulation post if you don't have a machine that's supported by anything we already have. So just something to bear in mind going forward. Okay, so that really kind of concludes how easy it is really to use machine sim. It's that easy. It's download the model you want and position the fixture on it, position the part on it, then position the attach point on the table where you want the part to go, and hit the OK button and simulate. It's really that easy. Let's have a look. Is there any... just checking if there's any
discussion, but it looks like George has kind of kept up with it while you were
great. Oh, great. Thank you very much, George. Very kind of you. Okay, brilliant. So we got onto the topic of we've got a lot of machines that are supported, but what happens in the situations where we don't have a machine that is created as part of the Fusion 360 library? So how do we go about creating our Fusion 360 models or our machine sim models? So first thing to bear in mind is that here I've got just a Haas machine, a VF3, and I can go and I can take some of these components and I can just drag them around, right? So they're not constrained in any type of way. Two things to bear in mind when we do start setting up this these models is that the Z-axis, and I did mention this earlier, is that the Z-axis, and I think it was to either Tom or to Stuart, the Z-axis should always be pointing it up. In this case, my origin is at the center of the table, but it doesn't need to be. As long as the Z-axis is pointing up, doesn't matter where that origin is. Yeah, that's the main thing. The second thing is that as part of the tree layout of how the models should be expected, you should have a top-level component with a number of bodies in this. You can see my enclosure includes various bodies, and so the x-axis as well. So if I turn off those individual axes, so let's just turn off the enclosure and turn back. Yeah, here you can see we kind of got the x-axis, then we've got the y-axis, we've got the c-axis, or the A and the c-axis, and then lastly the z-axis. Now, one thing I did want to kind of point out before we actually start creating this model is how we actually structure the way these models are built. So first of all, what you can see is we start off with the base, right? And if I just rotate this, you can get a really good idea on that. So you can see the base is highlighted. Now, on top of the base, we have the y-axis, and the y-axis obviously slides along the y-axis. And that's obviously sits on top of the base. Then on top of the y-axis, we have the x-axis. And then on top of the x-axis, we have the a-axis, which swings. And then on top of the a-axis, we have the c-axis. And then lastly, on its own, on the spindle, we have the z-axis. So that's the kind of mentality that we use when we build up the machines in the machine builder. So some of you that don't know yet how to use Machine Builder, if you go to your Preferences tab and enable the Machine Builder and the Machine Simulation functionality, I'm just going to wait for my preferences to turn up. God, that's taken a long time. Where's that gone? There we go. So if you go into your Preferences tab and type in Machine Simulation, you should see Machine Simulation. So you want that checked, but also you want Machine Builder checked. Kieran can't spell. So there you go. You basically want Machine Builder and Machine Simulation checked. So those are the two options. They both are public preview options. The Machine V2 is the next generation of the Machine Builder functionality that we're working on in the background. It's also public preview, but not quite ready yet. So hence why it's still on public preview. Okay, so how do we get hold of the Machine Builder? So if we navigate to the manufacturing environment, and then from the utilities, you'll see there's the new Machine Builder functionality. So if I go into that, you'll see there's a number of icons overhead. So the first thing we want to do is jump into the machine, I can't remember what the tool, machine library button. And we're going to first of all hit the plus button. And this is going to enable us to create a brand new milling machine. So we can go ahead and give this a generic name like Kieran's first machine, something ridiculous. And then we can call it, Kieran's special machine. Okay. Now we can go ahead and specify loads of dimensions for it. We can specify some of the capabilities. At the moment, only milling is supported, but we are working to support the others going forward. We can specify the number of tools, but I'm going to leave that all blank for now. We can even specify the workpiece envelope. But the really important bit here is I want us to really focus on how the kinematics are structured. So remember, we spoke about having the base first, then the Y sitting on top of the base. So first of all, what we need to do is we need to drag the Y above the X. So the Y sits first, then we had the X. But there's a Z here. There's the Z axis. So the Z actually needs to be on the spindle. So I'll drag that over to the spindle. And now you're thinking, but hang on, we've got a as well as a C. The A sits on top of the X. So right click on the table and we can add a rotary axis. Automatically it names it A, and we can add another axis as well. Now, again, that names it suitably C. Now we can go and change these to different presets. So they can be A, B, or C, and we can flip them around any way we like. Okay, so our kinematics kind of looks correct at the moment. We now need to define how these kinematics move in terms of their range and limits. So for us, what we're going to do is we're going to specify a range on the y-axis of -400 and a +400. Now you can go and get these from the manufacturer PDF or specifications. Go. It's freely available. So this one is on the x-axis, we've got -600 and +600 millimeters of travel. And then on the y-axis, so here it's important to bear in mind how these axes actually rotate. So just something to bear in mind, the a-axis will always rotate around the x. The B axis always rotates around the Y, and the C axis always rotates around the Z. So in this case, because we've got an A rotary, we are rotating around the X. So in this case, how are we rotating? We're rotating with a limited -90 and +90 range. Okay, so that means the trunnion is actually flipping between 90 and -90 and +90 degrees. The preference is quite important because you can define to the post how you want, which option you want. So it can either be a positive or a negative, but you can give it a preference. In this case, I want it to be negative. So I want the table to swing away from me so I can see some of those toolpath movements as it's being simulated. And then kind of jumping into the rotary C-axis, here we're going to have a unlimited range because it rotates through 360 degrees. And last one we need to do is jump down to the Z. And I think we're going to leave this we're going to change that to -400, and we're going to leave our max at 0 because it's actually in its own position up top, and we actually want it to come down. So the last thing I want you to just be aware of is the post processor. So in this case, we can go and pick all of our simulation ready machines, our posts, but in this case, I'm going to go ahead and pick that machine simulation post, and I'm going to go ahead and click on OK. So you'll see it actually creates that machine. So we've now defined our machine kinematics. Okay, so we're going to go ahead and select it. So you may say to yourself, oh, hang on, I actually, I need to actually move it. My Z is not pointing in the right direction. So here we've got the ability to now move components. You can select each of these components. You can select them from the tree, and you can rotate them into the correct position if they weren't in the position before. So really nice, useful bit of functionality there. So the next one really is kind of defining where these axes live. Okay, so the first thing we need to do is specify the tool attach point. So in this case, it could be at the bottom there. Then we need to define where our part lives. Now, remember I said when we had a look at the original machine simulation, we spoke about the initial position that a part gets imported to when we choose a machine. And it's at this point here that we select the part location. So this is that initial position that parts will default to when they come in. Okay, again, we can kind of open up our tree and we can start to kind of cherry pick some of these selections. So as part of the static, we can go ahead and pick our enclosure. So I can turn that back on if I want. I can pick the base, but I'll go and turn them off as we're going along. For the Z-axis, we go and pick the Z-axis. For the Y-axis, again, we go and pick the Y-axis. For the X-axis, we can pick the X-axis. And when it comes to the A-axis, we'll obviously pick the A-axis. But interestingly, we get this extra little rotational point checkbox or sort of selection point. And when we select that, it's actually going to ask us to select the point around which the axis rotates. So in this case, it's around that center point on the trunnion. And again, we'll go and pick the C axis. And again, we'll give it its own rotational point as well. Okay, so once I've done that, I can click on OK. And next thing we can do is go and see how we're doing. So let's go ahead and check our Z-axis moves. Okay, our Z-axis definitely moves. Let's turn back on our enclosure. Let's go ahead and check the Y-axis. The Y-axis translates. Let's go check our X-axis. The X-axis translates nicely as well. And our A-axis moves as well. Now, if you have a situation where the A-axis moves and something doesn't look right, then your machine kinematics are incorrectly set. So we can rotate the table, move the A-axis, and translate all of those as well. So that looks really good. I'm really happy with that. And that's really as simple as easy as it is to set up one of these machines. So we're going to go ahead and say yes to that. Now, whilst we're waiting for that to go ahead and save, we're actually going to go ahead and look at this separate model. Now, what we've got over here is we've got a particular model, and what we want to do is go and use one of the machines we've just created. So you can now go ahead and choose this machine that you've just created, you can go ahead and select it. And hopefully we'll give that a couple of seconds to bring itself in. Again, there we've got the model we've just chosen. Here's the machine we've just created. And again, this is just the same process that you followed when we chose to do machine simulation in the beginning. So it's really that simple and that straightforward. Any questions so far? Sorry, I'm just going to scroll down.
It appears to be pretty quiet at the moment.
Great, perfect.
Everybody's absorbing your great demonstration.
Yeah, no, well, thank you very much. So that's really as easy as it is to create a machine, use machine simulation, and it's probably now actually worth jumping in back to our presentation and actually talking about some of the things that are coming along. Now, we do have George on the call, who is the product manager for machine simulation and post-processing. So he can jump in as well if I've missed anything. But let's talk about what's coming, right? So one of the biggest things that everyone keeps asking for is collision checking, and that's huge for us. That's something we're working on at the moment. We've got loads of teams working on it. It's probably the most single important thing to us going forward. So we are frivolously working towards implementing collision checking. So it's something we're aware of and we are working towards it. So we plan to have really kind of rich notifications in the simulation toolbar at the bottom, where you kind of you're kind of notified about what's in collision. We don't just want to say, hey, there's a collision somewhere, go and find it. We want to be explicit about, hey, there's a collision with a C-axis and the tool holder, or there's a collision with the C-axis and the spindle nose, for example. So we want to be quite clear and explicit about that. So that's on the horizon. Stay tuned for that. Look out for that. Next on the list is the simulation that you currently use can become quite a cluttered dialogue. So it's already quite a, I wouldn't say a cluttered dialogue at the moment, but with all the options in there, you often find yourself having to scroll further down. And some of the improvements that we're looking to bring will actually kind of separate the simulation into its own kind of mode. And that just means we're going to have a lot more flexibility to do certain things. So a real good example here is when we're post-processing, we could do that separately to us actually doing simulation. We can then make some changes to the toolpaths while we're in simulation. So for example, if we have an issue, for example, we'll know where that is. We'll report the line, we'll report the toolpath, and we can offer advice about how you go about fixing that, right? So we're working on that at the moment. And then lastly, we're actually looking to kind of make some of the G-code displays we're looking to make it displayed inside of Fusion. That'll just give a lot more clarity to users who manually program, who like to look at the G code, who like to step through their code, to error check and diagnose errors, to make sure that their post is doing what it's supposed to be doing rather than something it's not. And this is really, really applicable to very high precision parts and really kind of close calls when it comes to some multi-axis machining. The simulation mode, just to come back to that simulation mode, it also allows us to do other things. So when you are in simulation mode, we're kind of, the intention is for us to kind of give the user the ability to measure as well. So how far am I from the spindle nose? Hit pause on the simulation and measure how far you are from the model, for example, so you have a good idea. So that's just an example of some of the stuff that may be coming. And then we're just looking to simulate additional movements, right? So I did talk about the fact that we're not simulating linking moves, go home G53Z zeros, for example. So that's all of tool changes are a really good example here. And that's just some of the stuff we also want to kind of tackle as part of the additional improvements to the movements that we want to bring into machine simulation. So we're again working on this quite heavily. So stay tuned. Yeah, it's coming. And that really brings us to the summary, really. We've actually been through quite a lot, to be honest, in 44 minutes. We've seen how machine simulation works, how you can use it. We've gone through a machine builder exercise where you kind of set up your machine to begin with, specifying all of those axes, translating them and moving them to make sure they're all okay. and then going on to show you how you can actually use that machine that you just created. So yeah, that's already good. And I think that's it from me, really. Is there any questions that anyone's got before we hand it over back to Chris? And George, feel free to chime in if there's anything you feel that needs to be said as well.
I think it was a great presentation. I think I'll add a little bit on the what's coming. When we're talking about the simulation of additional movements, we're specifically looking at reverse engineering the G code, which for those that have a vested interest in simulation, that's something you've probably heard asked quite a lot or questioned. At the moment, we run through the post processor, which gives us accurate simulation of the cutting moves. But we feel like reverse engineering the G code and actually simulating directly from the G code will be the best step forward into simulating these additional movements. So that is something we're working on. And then the collision checking side, the slide, sorry, there was that small picture that you said with the simulation bar at the bottom. Just as a hint on how close it is, that's not like a photoshopped thing. It is in product now internally for testing. So we are running through testing. I think the most important thing for us is making sure we catch every collision before it goes out. The worst thing for a simulation product to be is incorrect and you lose trust in it the first time it misses one. So we've got to do a lot of validation and then be open up to get people's hands on it. But if anyone's interested in learning more, feel free to reach out to me. We do go through internal testing and something called insider testing, and before it goes out to the general public. So welcome anyone's thoughts and feedback on that when you want to try it out.
Great, thanks very much, George. I haven't seen anything more come through through the chat. No. So with that, I think I'll hand over back to Chris. If that's all right.
All right. Yeah.
Thank you very much.
I'm not even into the machining side of things, but I thought that was a great demonstration. I've always, I follow the forums and I see a lot of the questions that come up. So this was, to me, it was great to see what you're all talking about.
Thanks, Chris.
I feel like I learned something here today. All right. Well, let me take it back and we'll jump forward from where we were before. We do have some more upcoming Fusion 360 sessions in our community conversations. I posted earlier a link to the calendar, and I'm going to put that in the chat again. But here on this slide are a couple of the upcoming sessions that we have. I'll post this real quick here. Next Wednesday on May 18th at 10 a.m. Pacific, we have Getting Started with Modeling in Fusion 360. That is with the ever popular Phil Eichmiller. And his sessions are always great. I mean, you can ask Phil anything and he takes all your questions and does a great demonstration. So tune in for that one. And then the following Wednesday, there's going to be our series on fusion electronics with Richard Hamrell and Jorge Garcia. And again, they do a fantastic job taking all your questions and talking about what's coming up and what they're working on, things like that. So these two sessions upcoming, we have plenty of space available. Go into the Community Conversations calendar and RSVP and set yourself up to attend these two sessions as well. Again, I want to say thank you to our speakers, to everyone who attended today. There is going to be a survey at the end of the session when you leave. So please take a few minutes to fill out this survey, because that lets us know how we're doing on these sessions, what you like, what you don't like, and whether or not we are getting it right, basically. So please take a moment to fill out the survey at the end. I know it's just another survey, but it's a little one. It's real quick. Please take the time to let us know how we're doing. If you have an idea for a community conversation or you would like to become a speaker, we welcome you to fill out our proposal form, and I'm going to put that in the chat for you right now. Bear with me one second. There you go. So if you have an idea for one of these sessions and you want to fill out this proposal form, go ahead and do so, and Sean will take a look at it. You can also reach out directly to Sean at sean@autodesk.com. You can ask him questions about, like, what are we looking for? How do you structure one of these? Oh, hey, thanks, Sean. Put a shorter link to the calendar in the chat for you. So We also want to share with you some resources to our other community resources that we share. We want to see you in the forums. Obviously, most of you are probably already familiar with our community forums. Our community groups, we have 2 new blogs that we've launched in the last several months, the Community Voices blog and the Community Journal blog. Now, the Community Voices blog is by the community for the community. It's community members writing articles on various topics, tips and tricks, industry notes, whatever's on their mind. And the Community Journal blog is written by us in the community team with news and views and announcements, community profiles, member profiles, things like that. We encourage you to keep an eye on that for upcoming events as well. We also have our student group hub, and again, more community conversations coming up. So with that in mind, let me drop a wealth of links into the chat for you. Take a moment to look through those and bookmark those, especially our 2 blogs, the Voices and the Journal. Great information in those resources for you. So with all of that said, thank you all for coming.
Thank you very much, everybody.
Thanks
Have a lovely day.
Speakers, and thanks to Sean for helping me in the chat window.
Thanks, Sean.
Sean's always hiding in the background, but he does a great job keeping me honest. So.